We're going to start with a little review of differentiation. Let's say we have a function y equal f of x. The derivative of f of x can be written as follows: f prime of x, or dy dx. These are the two most common notations for the derivative of f of x. Here's the definition of the derivative. We read this as the derivative of f of x, or sometimes we say f prime of x because of this little symbol here. This is the prime symbol. And here's the definition. F prime of x is the limit as h goes to 0 of f of x plus h minus f of x over h. All right, so this is the definition of the derivative. And the main interpretation is the value of f prime of x is the slope of the tangent line to f of x at the point x comma f of x. So let's just look at a little picture of this to understand the definition of the derivative. So I'm drawing a little picture of the function, the curve, f of x. And let's say this is our point x. And let's say next to it we have x plus h. So we're assuming h is small and x plus h is close to x. And let's say here I'm going to just draw a picture of the tangent line at the point x comma f of x. So this is the point x comma f of x. And let's say on the curve above x plus h, we have the point x plus h comma f of x plus h. So now what we're going to do is write down the formula for the slope of this secant line, this little line between, or the little line that goes through the line that goes through these 2 points. All right, so let's write that down. So that's basically the slope of that line is obtained by subtracting the y coordinates and subtracting the x coordinates. That's x plus h minus x, which is just h. All right, so notice that that is this piece of the definition of the derivative. So we have the slope of this little secant line. Now, as h goes to 0, that means as x plus h gets closer to x, this secant line gets closer and closer to the tangent line. All right, so that's why the definition of the derivative is, as we wrote above, the limit as h goes to 0 of the slope of the secant line. All right, so let me just write here that this one is the slope of secant line. To find the derivative of a function, we can use the definition of the derivative, but usually that is a lengthy process. So we have some shortcut rules, and that's what we're going to review. Now we're going to use the shortcut rules to find the derivative of various functions. So in this first example, we basically have a sum of powers. X to the fifth is a power. Square root of x we can consider as x to the 1/2, so that's also a power. And here we have x to the 1 and a constant. So we're going to find the derivative using the power rule for differentiation that that is as follows. The derivative of a power is obtained by bringing that power down in front and subtracting from the exponent. All right, so that's the power rule. For differentiation. All right, let's apply the power rule in this example, and we're going to take the derivative term by term. So first, the derivative of 3x to the fifth will bring down that 5, multiply it by 3, so we have 15, and subtract 1 from the exponent. All right, here we're going to view square root of x as x to the 1/2, so we're going to bring down that exponent of 1/2 and subtract 1 from the exponent. So that's 1/2 minus 1, or 1/2 minus 2/2 is negative 1/2. The derivative of 2x is just 2, the constant in front. We can do that using the power rule, or it's best just to remember that the derivative of the linear term is just the constant in front, and the derivative of a constant is 0. So that would be minus 0, or I just won't write that. So that's dy dx. In number 3, we have a quotient, but notice that in the denominator we have one term. So we can divide by that one term and obtain a sum of powers, and then we'll just use the power rule. All right, so this one term we can rewrite as x to the 1/3. All right, and let's start dividing by x to the 1/3. So we have y is equal to, first term, 5, and x to the 3 minus 1/3, that's 9/3 minus 1/3, that would be 8/3. Okay, second term, here we have x to the 1, and here we have x to the 1/3, so we're doing 1 minus 1/3, or 3/3 minus 1/3, and that is 2/3. And here in the third term, we have 1 over x to the 1/3, and that would be x to the minus 1/3. So what we've done is we rewrote as a sum of powers so that we can apply the power rule. So now we're taking the derivative. All right, derivative of the first term, bring down the 8/3, so we have 40 over 3, x to the 8/3 minus 3/3, that's 5/3, minus 7 times 2, that's 14, over 3, x to the 2/3 minus 3/3, that would be minus 1/3. And here bring down the minus 1/3, x, minus 1/3 minus 3/3, that would be minus 4/3. In number 4, we have a function that's a product. We could multiply this out and get a sum of powers and use the power rule, or we could use the product rule, and we're going to use the product rule. So let's remember how that goes, and I'm going to write it like this. If we have a product, f times g, and we're taking the derivative, the derivative is equal to the first function times the derivative of the second plus the derivative of the first times the second. All right, so this is the product rule of differentiation. And we're going to apply that here. So this is our first function, this is our second. All right, so we have dy dx is equal to the first function times the derivative of the second, and that would be 15x squared minus 4. We just use the power rule here to get the derivative. Okay, now plus the derivative of the first, so that would be 6x, times the second, 5x cubed, minus 4x. In number 5, we also have a function, but notice that the denominator has two terms. So we can't simply divide like we did in the previous example in the example where we had a quotient with only one term in the denominator and get a sum of powers. So here we have to use the quotient rule. So let me write down the quotient rule. So we'll write it like this. Here we have a quotient. The derivative is equal to, in the denominator we have g squared, and we start off in the numerator with g, and then the derivative of f minus the derivative of g times f. So this is the quotient rule for differentiation. So let's apply that here. So we'll start with the denominator, square that, and then bring it up to the top. And now the derivative of the numerator, and that's just 10x to the fourth, minus derivative of the denominator, and that's 12x squared, times the numerator.